An object with temperature 72 degrees Fahrenheit is placed outside in a cold night where the temperature is negative 20 degrees Fahrenheit. Let's make a timetable for this, okay, just timeline. So the initial temperature of the object was 72 degrees, so T when time is 0, okay, which is same as T sub 0, that's 72 degrees Fahrenheit, is placed outside in a cold night where the temperature, the outside temperature of the medium Tm is negative 20 degrees Fahrenheit. At 11:05 the temperature of the object is 58 degrees Fahrenheit. We don't know when we put this object outside, but at the time 11:05 p.m. the temperature was 58 degrees Fahrenheit, and at 11:07 after, that means pretty much after 2 minutes, the temperature is 50, okay, 50 degrees Fahrenheit. Now the question is, at what time was the object placed outside? So we need to find this. This might not be the initial. We can say this is T0, but for me, since we know this temperature, I want to make this initial temperature, and finding this temperature would be going backward negative time, but we can adjust that, okay. Initially the temperature was 72. Since I know the temperature 58 and 50 degrees here, and it's happening in 2 minutes, 11:05 to 11:07, I can find the rate at which the temperature of the object is decreasing, okay. So I want to make this T naught, and we could make this T naught as well, but that doesn't help because we don't have the temperature here, and it would be more complicated. So for me, what I'm doing here is, now let's say this is T at 0, T0, and after T at 11:05, 11:07, that after 2 minutes, T2. From this I'll find the rate at which the temperature is decreasing, okay. By the Newton's law of cooling, the temperature T at any time T is given by, let me make it slightly bigger, okay. The temperature at any time T is given by Tm plus T naught minus Tm times quantity e raised to negative kT, and after 2 minutes the temperature is 50, so this temperature is 50. Temperature of the medium, that's outside, negative 20 plus T naught, I'm assuming this as the initial for these two temperatures, 58 minus medium temperature is negative 20, so negative minus negative means plus 20, e raised to negative kT, time after 2 minutes, times 2. So move this over, so 50 plus 20, 70 equals 58 plus 20, 78 times e raised to negative 2k, divided by 78, e raised to negative 2k. Take natural log both sides, so I'm going to write this first. Negative 2k is equal to natural log of left hand side, 70 over 78. Now divide by negative 2 to isolate k. So the k is divided by negative 2, the same as multiply by negative 1/2. Natural log of 70 over 78. Okay, that's the rate at which the temperature is rising. You can use decimal. If you take the decimal, use at least 4 digits. Now let's go back. So this will be negative time because we said this is the initial, so this will be negative, but we know that negative means that that object was placed that time earlier, okay, and we can figure out the time. This is still T naught, and this will be T at any time T, and we want to determine this time. Again, using the same formula, T temperature at any time T is given by Tm plus T naught minus Tm times quantity e raised to negative kT. Temperature is 72. Tm is -20. T naught is this 58 minus -20, so this will be plus 20. E raised to -k, that's in fact k is here. T that we want to determine. Move this over, means add 20 both sides. 92 equals, that's 78 e raised to -kt. We are trying to determine k. Sorry, k is trying to determine t. Divide by 78. 92 over 78 equals e raised to -kt. Take natural log of both sides, then this is -kt equals natural log. I want to write in the right hand side 92 over 78. Then t is, now we divide by -k, same as multiply by -1 over k. Natural log of 92 over 78. Now use your calculator, because k value is here and it comes out to be t equals -3, about -3. That means this temperature happened 3 minutes earlier than 11:05. Okay, so 11:05, so the object was placed outside 3 minutes earlier, means 11:02. So thus the time we are looking for is 11:05 minus 3 means 11:02 p.m. Okay, final.